Good morning, everyone. My name is Mr.Bellic, and you are watching Bellic Robotics. Welcome to our second video of data pre-processing with command under the data science playlist. Today's video is all about data integration. So, with the name itself, it's telling that data integration means to integrate data. Okay, so how to integrate data and why we have to integrate data, what are challenges for data integration, we will cover all these concepts in this video. So, watch the video completely and let's go. Okay, so in data pre-processing, we have covered data cleaning already. We in today's video we are going to cover data integration, and in next video we are going to cover data transformation. After that, we will cover these two: data discretization and data reduction also. Okay, so without wasting much time, let's move to data integration. Okay, so moving to the definition, which we do always. So, data integration is a process of combining data from different sources to provide an unified view. So, what do you mean by different sources? Different sources we means that we can collect our data from many databases, clouds, Excel, sheets, SAPs, etc., etc., etc. So, what we do in data integration is like we collect data like relevant data means I want a data for some like image analysis. For that we collect all the image data we found on the web, and then it's like we collect it in the different database or different formats. After that we transform them in a consistent format, like in same form that our model can access easily. After that transforming, we collect them in a single one database. So unify we store multiple database this data in the form of one unified view. So what do you mean by unified view? Unified view means that in one database and in one consistency. Okay, so our definition says the same. Data integration is the process of combining data from different sources to provide a unified view. This involves retrieving to retrieve data from different sources, transforming the data from the original source to the structure we want, and consolidating data from various databases, system or application, etc., etc. And this is useful for analysis and decision making. So this was all about the definition. Let's understand three topics before jumping on data integration. First of all, in the definition, we studied the word retrieve. What do you mean by retrieve? Retrieve means extract. Extract. What we are extracting. So our first step is like we will extract data from multiple resources, multiple to one database, and at that this step, what we do is like we are not only having the data from these sources to this source randomly. We are making some validation rules. What validation rules we are using? Like some data cleaning rules, like data is complete or not. If data is complete, then only data will come in the bigger database, or else it will be rejected. Data integrity means foreign key or primary key. If you have studied about the databases or SQL queries and etc., you will knowing about foreign key and primary key. So it's like all the foreign key and primary key are is like in the well structured and well shaped and connected. Then only the data will be stored here. And deduplication, of course, it's the part of the data cleaning that we should remove the duplicate value before storing in this. So we should clean the data before storing the is like before collecting from these things. Okay, so in the extract part, we are extracting data from original databases, use applying some data cleaning and data integrity techniques, and storing in a bigger database. Okay, transform. Okay, in transform we process and organize data in usable is like which can be used. It's like I'm for example, I will say take a image of a policeman. So I can't analyze the image of a policeman, and I can't give the image of policeman to a model. So we have to transform in the form which a model will understand, which means that we have to transform it in the form of numpy array or more easily to say is like in the form of 0 and 1. So in transformation, we transform our data so that our model can use it easily. And load state is like with the name, like loading the data. It's like loading the extracted and transformed data to the bigger database is called load. So moving to next. So this is all which we have covered till now. Is like for in data integration, we have data from many sources like databases, different databases, PDF is like voice notes, cloud, SAP, and after that we will apply data integration technique. These five techniques we will cover in this video one by one. So either we will apply ETL, ELT, streaming, application integration just like a, API. Okay, so we will study that also, and data virtualization. Okay, so we have to apply one of these technique, and then our data is stored in one cloud or one database or only one software. After that, from here our application or our model which we have made to analyze or model the data, take the data from these big cloud or big databases. So let's start studying about these five one by one. So let's go. Okay, so first ETL. The full form of ETL is extract, transform, and load. We have already seen what is extract. Is like extracting the data from the databases, transforming and loading. Okay, so ETL means to extract data from the databases like SQL, NSQL, or SaaS platform. And after extracting in ETL process, we have an staging area. Okay, so in staging area, what we do in ETL process staging area, we transform our data in the form which we required. After that, we will store it in the data warehouse. Okay, so it's like what we do. Like first of all, we don't take whole data. We from here we take one batch. It's like I said 32. So from here, 32 data sets came in the staging area. Here, the batch of 32 images or the 32 data points will be transformed in a form we require it for data analysis or data modeling. After staging area, the data is transformed in the form we want it. After that, we will load it into our data warehouse, where it is stored for our data model or data analysis software, which will use from data warehouse directly. So this was all about ETL, and there is one point about ETL which I have written here, which is a different. It is differentiated from ELT. Okay, so what it is here? This allows fast and accurate data analysis in the target system and is most appropriate for small data set, which require complex transformation. So it is fast and accurate for data analysis. So ETL we generally use ETL for data analysis purposes, and it targets a system which is most appropriate for small data set. Means the data set should be small. Means it will fail on the large data set. Means it will not fail, but it will not much accurate on the large data set because we are making the batches. It's like if we are saying we are making batch of 32 images or 32 data points. So imagine that from our source we they are coming 1 crore 2 crore, or it's like in USD it's like 1 million or 2 million data points, and we are only converting 32 batches at a point. So it would be is like very time consuming. So that's why for ETL process we use it for small data which have complex transformation. For complex transformation we have a staging area which we transform here, and it's like we the batch come here and fastly gone from the transforming stage, and then it's collected in data warehouse. So it in ETL process we do data integration in the three process: extracting data from the source, then transforming data in staging area, and loading area in data warehouse. Okay, extracting the data from the source. After that, transforming the data in the staging area and loading the data at the data warehouse. These three steps was of ETL: extracting, transforming, and loading. Okay, and just remember that it allow fast and accurate data analysis in a target system where and is most appropriate for smaller data which is require complex transformation. Okay, I am saying it again and again because it's like important. It can be asked in your interviews or in your exam. After ETL, our second model is ELT. Okay, so what is ELT? Like ETL was extract, transform, load. ELT was is extract, load, and transform. Just exchange the letter L and T. Okay, so after reposition, we are having ELT process. Okay, in ELT, as name suggests, first of all we extract it, and after directly extracting, we load the data it in the data warehouse. Okay, so here we are just extracting. Remember in the uh, extracting part, we use data cleaning, checking the data complete or not, deduplication, and data integrity. Okay, so remember this part. So here in ELT, we just extract means like some basic data cleaning purposes. After that, we load it in the data warehouse, and it transform in data warehouse itself before the analysis. Okay, so it is used where data is large and time is means if time constant is important means you are giving a time constant that you have to do in this time only. So load is like to data clean it and just load it. It is easy that it's just extracting 32 batch and loading in it, extracting and loading, extracting and loading. So after that, if then we the person who want analysis is like first it have he have to transform the data in the form he want it, and after that he will use the analysis techniques. So this was all about ELT process, and let's we will jump on to streaming processes. Data streaming first. Before learning what is data streaming, we will see some concept. Okay, okay, so till now what we were doing is like in ETL and ELT, we take some batches like this batch of 32 and feed it in the process ELT or ETL process. Then we take batch 2 and then batch 3 and batch 4. So what's the problem here? It's like we are giving one batch one by one batch, which make the process a bit little bit slow. Like if we have a large data set or continuous data set, it's like data is continuous coming on. It's like in the modern days, you are seeing it's like various computer vision projects where like surveillance for the childrens and it's like army and hospitals. So their continuous images are coming and we have to process it continuously. So for that we want some technique which is like current is flowing continuously and there is no batches in the current. Just like this, we want a streaming platform. So our uh, first model which complete the this strategy is data streaming. So here I have written that instead of loading data into a new repository in batches, the streaming data integration move data continuously in real time from source to target. What I have explained just now, I have written here same thing. Like in data streaming, we just move continuously in real time source to target. And like here it is our T which is missing. You just complete it. Okay. So how it is done? Let's see it now. Okay, so data streaming contain three parts: land, assemble, and provision. First of all, we take data from sources like RDBMS, DBMS, data warehouse files, SAP. After that, it come to a land column. After that, assemble, then provision, then consume. Means like finally which can be used for analyze. And this is going continuously. It's like data is coming, landing, assembling, and like then in provision, after that analyzing. Okay, so this is continuously moving. And what are in landing, assembling, and provision, we will discuss deeply in next slide. Okay, first of all, land. So with the name land suggests that here our data is coming here. So the landing phase in data stream refer to process of ingesting data from various sources into centralized system or platform where it can be processed and stored. Okay, so land is what land is doing is like just taking the data from here and storing it in a temporary storage like there. Okay, so here three steps are done. Data ingestion, collecting data from multiple sources. Second, data capture, like capturing it, same thing. If it like continuous data, then data capture is there. After that, pre-processing. So it's like basic data cleaning and formatting, like for consistency. So it's like extracting part. What the steps we did in extracting part, we do in the landing part. Okay. Okay. So our second phase is assembling phase. In assembling phase, we will change our data to the form where the data will be good in the is like for analysis and modeling part. It's like we use data transformation as we discussed before in this video, and also is like for understanding data transformation more is like in more detail. The next video, which is about in data transformation, it will have three parts. Just watch all three parts and you will be like good to go with data transformation. Okay, so here data aggregation, data transformation, data enrichment. Data enrichment means that you are taking some additional data or additional information is like from the external source and adding it into the your current data so that your data will have more power. Okay, after that, provision. In provision stage, we just store the data and make the data accessible and deliverable for the data which we have to send to the analysis software or data model. Okay, so this was the three-step land, assemble, provision, just like extract, transform, and load. But these things are making it for continuous data, means they are not taking data in the batches, but they are like continuous stream of the data. So it's like data is coming, then in the land phase, it is like collect in the one form, and data cleaning is done. After that, in assemble, data transformation and enrichment is done. In provision, it's like data will become accessible. It's like using API keys and other things. So this was all about data streaming, and after that, we have come in application integration. Okay, so in application integration, we can is like we can use many application which are using same data. Okay, it's like I am using some data and someone else is using some data, and same data, and they are working different things. Like he is working on Excel and he's working on Word with the same data, but in the real time both the data are stored in centralized database, and they are is like in real time they are editing and making the changes so that each one of them will get the modified data. Okay, so it's like here is one example is like um, cases support operational need such as ensuring that HR system has the same data as your finance system. Therefore, your application integration must provide consistency. Means, of course, consistency between two users. Okay, so this is a nice example which what BI tools does. Okay, so here this is our BI tools, and this is our CRM system, and this is our data analyst. Okay, and here project is like some tools for project management, webinars, CRM system, marketing strategy software, payment processing. They are all coming to the BI tools, and at in the real time BI tools is like updating the data and analyzing the data, and is like in real time making live chat platform which have all the data which are being updated here and here, and also sending it's like email and showing on the website the same data which are going continuously updating here and here. So in data application integration, we use some tools like API tools and other tools which help us, so that whatever data we modify on one thing can be modified on the different applications. That's why it is called application integration, that we are integrating many applications. Okay, now our last point is data virtualization. Okay, so this is like a stream data streaming only, but here in is like in real life what this does is like it act as a means if you will ask only, then only I will give the access. Okay, in data streaming, what was happening in data streaming? Data was coming, landing, assembling, and provision is like load to go. But here, like this is our data visualization platform, and in this platform, like here our consumer, uh, and here consumer asked, give me the data about the sales of my company in the previous year. So visualization platform say, okay sir, I'm going to our database and warehouse, and from there I'm fetching it. It will fetch it from there and give it to the enterprise application. Okay, so this was all about the uh, data visualization. Okay, so summing up, all the five types are like in ETL. In ETL, we extract, transform, and load the data. In ELT, we extract, load, and transform. In ETL, we first transform, and in ELT, we transform the data later. In streaming, what we does is like we have a data continuously going and processing, and after loading it in the bigger databases. In application integration allow us to use many applications at one time. In data virtualization, we have a virtualization platform which allow us to ask the real-time data like data streaming, but here we have to ask like give me the access of this data, and then it will give that data to the user. So these were the five techniques of the data integration. So this was all about data integration, how we can do data integration, and at last we are going to study some challenges. Like what is challenges in the data integration we will face? Like first of all, data quality, that every data should be complete, and like quality should be good. Means like data should be consistent. So for achieve this, we are doing data cleaning and data transforming processes. After that, data transformation takes some like complex is like a complex thing. So it will take a good amount of memory or RAM and computational power. And like in data transformation, if all data are not converted in same like in same form, then it will throw an error. Scalability, of course, in scalability what I just said, that increasing the volume of data is increase the computational cost and cost of your memory. And it's like here is the risk of security and privacy leak is like data breach. So this is one of the good challenges which we have to see and which we have to solve. Okay, and it's like real time integration is hard and cost. Why I'm reading this, like you already know, like real time integration cost and resources, every point are similar. Okay, so mainly just in the challenges, just go to from data quality, that all we have to ensure that all the data is cleaned and of similar transformation. Okay, second, there should be no data breach or data leak, so that our client data is uh, have good security and privacy. We should be able to scale our project. Like it's not that we are giving our application to the company of 100 people, so we can't be able to give to 1,000 people. We can easily be able to scale it to the 1,000 people. So these are some challenges, like because it requires some uh, good amount of money and resources like GPUs and CPUs, which again takes some money. So these were the some challenges of the data integration. Okay. So in today's video, we studied what is data integration, the definition of data integration, and 5 steps if, how we can do data integration and some challenges. Okay. In the next video, I'm going to teach you how to transform the data with is like application, is like not application, like coding part. Okay. We will apply our data transformation techniques in the coding to Python notebook itself. So it will be applied video, and we are going to cover it in 2 to 3 videos because transformation have many things. Okay. So stay tuned for the next video and subscribe if you are new to the channel. Thank you. Bye bye.